I've got a project that I'm going to start on today, and this is something that I've been delaying and kind of putting to the side for a very long time, and I want to go ahead and do this and get it done. So what I want to do is I want to build some soft jaws for this Wilton vise right here. And I'm also, while I'm at it, I'm going to build some soft jaws for my Rock Island vise, which is the other one that you typically see in my welding videos. It's mounted on my welding table over on the other side of the shop. So this is 4-inch wide jaws here. So we're going to do some 4-inch wide jaws, and then the Rock Island vise is actually 5 inches wide. And I'll go over there and show you that vise so you see. But primarily we're just going to work on these. But the material that I'm going to use, I'm going to go ahead and make up for 2 pairs of jaws. So one of the problems with, there's nothing wrong with these jaws. You know, they're factory made. They got the serrations made into them. And a lot of times you need that if you're trying to grip something hard. But if you're holding something in a vise where you're not worrying about marring up the surface or biting into it, these jaws are just fine. A lot of times in a machine shop, in a hobby shop, you need to be a little bit more delicate whenever you clamp into something, and you don't want to mar it up with these serrations in there. So a common thing is that people make soft jaws, and usually you will see them made out of either copper or aluminum. And in this case, I'm actually going to use some brass. And the reason I'm going to use brass is because I have these brass blocks right here that I've had since me and my dad worked together at the old shop. And this was I don't remember what it was going to be, but I've got several of these blocks that were never finished. And they're 1 3/4 wide brass blocks, and they were drilled and tapped and bolted to each other. But since I've got several of these blocks that I've had for years now with no other use, I can actually take these blocks and make soft jaws out of them. So repurpose this material right here and make them in the soft jaws. So that's what the plan is. And what I would like to do is use this piece for 1 pair of jaws. So what I want to do is actually split it. And I thought that it would be fun to do that in the K&T milling machine. We'll use the horizontal milling machine set up, and we'll use a slitting saw and actually slit this thing right in half and cut it in half. And then from there we can do further milling that we need to actually mill it to the proper size, and then do our drilling and tapping, of course. And we may, since I'm going to be building these, I'm probably going to make them just a little bit wider than the standard jaw width right here. I want to make them so that they overhang just a little bit right there. And if you're using like a hacksaw or something right up next to this, you're not kind of getting into the casting. So I think an overhanging jaw just a little bit is not going to hurt one thing. So let me show you some more of this material down here. We'll talk a little bit more about this. So these are 2 of the pairs of the blocks. This one's tapped, this one's drilled to where it bolted on, and this is one where it's been bolted together for a very long time. I forget what we were doing. I want to say they were bored. They were machined. I can't remember. That was probably 15 years ago when we were working on this. It's been a long time, so it's just been sitting on the shelf. I've actually got another pair of these over on the shelf still. And so this, I was just showing you, that's kind of what they look like bolted together. So we're going to use these 2 pieces here to make our two sets of brass soft jaws for our 2 vices. Another thing that I was going to show you is that here recently on Tom Lipton, one of Tom Lipton's Monday Night Meatloaf videos, he was showing some, I believe it's phosphoric acid used to etch copper to kind of get the tarnish off of brass and copper. And I had, he and I communicate every now and then, and I was asking him, has he ever seen this stuff right here? This is brand name is Flitz Instant Brass and Copper Tarnish Remover. Somebody gave this to me several years ago, but this stuff works really good, and I haven't looked into or researched it, so I don't know if this is that acid that Tom was talking about. It very well could be, but this stuff does work really good, and that's what I used to clean up this to show Tom this the other day. And I'll give you an example right here. Let me grab a rag too. But you just take this stuff and just spray a little on, and you can see how it kind of instantly starts removing the tarnish there. And then I can take, I'm using my PPE gloves right here, and you can take it and just kind of, rub it in a little bit if you want to. And all you got to do is just rinse this off with water, and water will neutralize it. Thing to remember with this stuff right here is that it will stain and rust bare steel very, very easily. So you got to be careful if you use this, if you get any overspray on your steel or any tools, because you'll come back the next day and it'll look rusty. But you can see right there, see how it's kind of dripped down, and I'm just rubbing it in. And I tried to find, I had some copper around here somewhere, and I was trying to find a little bar just to show you for an example, but I don't know where I set them. But anyway, just some more stuff that I wanted to share, since Tom was recently talking about, a way to clean copper in his video, and this is just something that you can buy, commercially available. It works real good. So I'm going to go rinse this jaw off right here, but you see it cleans it up pretty good. It does a really good job on copper as well. And then you can come behind it and just kind of do a little bit of buffing and brighten it up a little bit. All right, so I got my two brass blocks here rinsed off with water and just kind of drying them off right there. So I was going to show you, this is the cutter that we are going to use today to split these. This is an 8-inch diameter. It is 3/16 wide. It's a slitting saw, and we're going to use this to actually cut these suckers in half. Okay, we'll go right down the middle of this thing. This is a big enough cutter that I can come in there and cut it, and also I'll be able to clear my clamps up on the top. There was a couple ways I was considering doing this. One would be just clamping it end to end in the milling machine vise like this. You could have two of them in there to equalize the pressure on the other side, and clamp it like that and come in there this way, and just split it. That's one way you can do it right there. But I wanted to go take it a step further and use the fireball fixture plate that I machined, and show you that we can hold this down on that fixture plate and use that to hold this and cut it in half. So we'll go down to the mill and start setting it up. So here's our setup for today. Going to use the 8-inch milling vise right here with my fixture plate mounted into the vise. And this is where I was talking about, I had originally thought about maybe just clamping it right here in the vise and splitting it that way. But I wanted to go ahead and utilize my fixture plate for some of the reasons why I had machined this. So I've got all the clamps ready to go, so we'll go ahead and start setting it up here. So what I want to do is hang this block right off the edge of this fixture plate like that, okay, so that we can just have a clean mill, nothing in the way. I'm going to have some clamps up here, but I thought this would be a good way to use my fixture plate right here. So we're going to be installing the cutter, and always cut in a push method, a conventional mill. I don't do a climb mill, which is where the cutter would actually be coming down into it like that. And I don't like doing that because you're pulling the backlash into the work, and you can easily cause damage and break a cutter and just have all kind of problems. So I like the idea of having the clamp up here on top of this to kind of keep it from lifting up, should I say. All right, so we're going to set it up right there. Let me show you what we're going to do here. I'm going to go ahead and make a fence using these dowels, these 1/4-inch dowel holes, and I'm going to space it off with a parallel. I've got my 1.25 inch parallel right here, and so that is going to create a square fence. By the way, I've already indicated the vise, so we know that the vise and all this is machined true to the plate underneath it. And then we can set this right up here like so, and I'm looking down, and actually let me measure this and double check that I'm clearing that. So just over 5/8, about 635. So my cutter will just clear this once I come in and make my second cut. All right, so we're good there. So we'll set the block up right here, and then I've got a couple clamps that we're gonna put up here, a couple of these right height style of clamps, We'll use 2 of them, and I've already found the bolts, the right length bolts there, and I'm using bolts so that I can clear the arbor and the spacers up there. All right, so we got that one just holding it down. Got one more. All right, and one more thing that I want to do is I want to create another fence or a stop on this end just to kind of keep the block from trying to push this way. I don't think it's going to do it, but you never know. Best to have a good stop there. So what I'm going to do is set this this 1, 2, 3 block up right here. I'm just going to square it up with the parallel and the corner of the table, and then I've got this 1/4 inch bolt and some washers, and it lines up with this hole right here. So I'll go ahead and tighten this one down. So that creates a stop that the brass bar can push against, like that. So we're just going to shove it in there, hold it square. We'll tighten our clamps down, and we are almost ready. We just need to go ahead and snug our clamps. All right, so that's going to be our setup right there. I plan on making 2 cuts. We're gonna make 1 cut to create 1 jaw, and then we'll offset it again, and then make another cut that will remove the center section here that we don't need, versus just splitting it in half and doing some milling. I just thought it'd be nice to go ahead and cut it 2 times. And by the way, it looks like I'm gonna have to move those clamps back just a little bit because they're over in there real close to where those holes are. So what we'll do is we'll touch off, and I've already got my offsets written down what I need to do. We'll go 0.887 in, and that's gonna make both of our jaws. We're gonna do 700 thousandths on our thickness of our jaw. So once we make the 1 cut, we'll offset it again 0.163, and that'll put it on the other side of the hole. Make another cut, and then that'll leave us 2 700 thousandths thick brass blocks right there. Just pushing my clamps back, and one thing I forgot to do is I got a couple pieces of brass shim stock here that I wanted to put under the toe clamp. It's always a good idea to do that and protect your machine surfaces against your clamp faces there. I've already taken all of my arbor spacers and lapped them over on my lapping plate. I keep a piece of 600 grit sandpaper taped down to my lapping table, and it's a quick, easy way just to kind of remove any surface contamination or any little dings and burrs. And it's important on these arbors that you have good true faces on them. Go slide that one on, and this is going to be our running bushing right here for our outboard support. And then the nut, and then you don't want to tighten it up until you actually get the arbor support on here, because you could bend it if you do that. Just making sure all the dust is off of them there. Put a little bit of white oil right here on the running bushing, put a little bit in the brass bushing there. All right, we'll go ahead and snug this one up top. All right, and then we're gonna run the arbor support arm back onto the running bushing just like that. Okay, and then we'll lock the top clamps here. Should be good to go. Now I have to fire it up so I can tighten this nut, because this one, the spindle locks with hydraulic pressure, otherwise it'll try to spin on me. All right. Let's go ahead and get our cutter touched off here. Looks like the cutter's going to have just a slight bit of wobble to it. This will be our first cut, our first offset, 887. Let's talk about our speeds and feeds real quick before we get started on making our cut. Went ahead and wrote it down again so that it's a little bit easier to see. And again, I'm referencing one of my textbooks here that I love, Technology and Machine Tools. And this chapter right here goes into milling machine cutters and how to calculate your cutting speed and also your feed as well. So you can see milling cutters, cutting speeds, high speed steel cutter, and carbide. And we're going to be, I'm using bronze here. I'm cutting brass, I believe, but so it says 65 to 120. So you see that's a pretty broad range of cutting speed. So this is just like a recommended range here, and you adjust it as you need to for either your machine or your setup. And there's other things that can go in, go into the variables there. This page right here, recommended feed per tooth. So you use this chart, or I use this chart whenever I'm trying to figure out what kind of feed rate that you would want to run the cutter at. Although the feed rates that the books always recommend are typically a lot higher than what you're comfortable with running on these old machines here. It's kind of scary watching a cutter go into a piece of steel at the recommended feeds that they recommend. So I usually back it down from that, but I wanted to show you how I got it anyway. So what we know is our recommended feet per minute for bronze and brass is going to be 65 to 120, and I'm going to use 100 feet per minute. And so to gather what our RPM is, the formula that you can use 4 if you don't want to use 3.82. That'll get you real close. But so it's your surface feet per minute, which I'm using 100, okay, divided by the cutter diameter, which in our case is 8-inch. So 100 divided by 8 times 3.82, and that'll give you 47.75, just round it off to 48 RPMs. And then so you'll take that and find your closest speed on your machine to that right there. And I'll have to see what we got over on the mill. So we'll just find something close to 48. And then our feed rate, in the book here for brass and bronze, right here in this, let's see. So for slotting and side mills, brass and bronze, it recommends 8 thousandths feed per tooth, okay? Which is a lot to me. It seems excessive to me, but that's what they recommend. So to get your feed rate, you got to know your feed per tooth recommended. Number of teeth for your cutter, in our case it's 48 teeth. In our RPM, we already figured being 48, so those are just coincidentally, they're the same number. So you take your recommended feed per tooth times the number of teeth times your RPM, and that's going to give you your feed rate in inches per minute. So in our case, 18.4, and like I said, I'm not going to run that feed that fast. We'll start off slow to get into the cut, and I'll see about kicking it up. We'll probably run anywhere between 5 and 10 feet per minute on our feed rate. By the way, we're running 44 RPM on the machine. That's the closest speed I had without going over 48. We'll start off kind of light on our feed and get it in there, and then we'll kick it up a little bit. There's the block, our first half anyway. I can see that the holes weren't actually perfectly in line there. But I'm happy. It looks like we've got success here. So we'll go ahead and make our second offset and get this other side cut to where it's 700 thick, just like this one here. So we won't even be taking the width of the blade here. We're taking 163 thousandths off the thickness of that. As a matter of fact, I'm going to close up the coolant on that side and just blow it on that side. I had to back off and move it out of the way. I noticed what it was doing. The saw blade is actually bending and warping, and it wasn't cutting the full width there. So I slowed the feed rate down and letting it try to catch up. If it looks like it's still trying to pull, we're going to have to come to this side and do a climb cut to finish it off. I do have a backlash eliminator on this machine, so I should be able to do that. I just don't like climb cutting. Looks like it's doing better. We're slowed down to 2 inches a minute and trying to give that cutter time to do its thing. All right, we're going to feed it the other way. So the second cut didn't do as good as I was hoping it would because the blade was actually deflecting. It was trying to push over because there was no resistance against this side of the cutter there. So we came down 2 times, and then I brought it back, and then we just went down the other way, using the climb milling method. So this probably isn't very flat right there. It's probably got a little bit of a bow. So I'm thinking maybe the second one, we just go ahead and just split it right down the middle, and then I'll just put it in the, I'll just mill it down to what it needs to be, just so that we avoid that those problems with the cutter deflecting like that. So we'll go ahead and let me get this cleaned up, and then we'll set the second block up and make our second cut. So on the second block, I just went ahead and just split it right down the middle of the holes there. And it's just easy enough. We'll just mill these things down. No need in just trying to mill one a different thickness there. And then, you know, trying to avoid that flex that we had in our blade. So 2 of them down, and this operation will be done. And from here, we'll just start doing our conventional milling on it to get it to the size that we need. All right, well, there's our 2 pairs of pieces of brass bar. Had a lot of fun doing that on the milling machine and sharing that with you. So I think that's going to be it for this video, and we'll come back and we'll start on these again on another video, and we'll start getting them milled into the proper sizing that they need to be, and get them shaped so that we can get them mounted on our bench vices there. And that's just, I'm just saving this, and you know, we may do the same thing again with another vise down the road. I've got 2 more pairs of these, this one and another pair. And if I don't have another use, we might just turn them into soft jaws, depending on how these actually work. I think they're going to work fine for soft jaws. So hope you guys enjoyed watching that, and we'll see you again real soon.